For electronic configuration, first I want to discuss about orbit. Orbit is the fixed energy level around the nucleus of an atom. This is also called shell or layer or principal quantum number. This is expressed by n. The value of n can be 1 to 7. When n is equal to 1, first shell, n is equal to 2, second shell. Like that we can go up to n is equal to 7. The maximum number of electron capacity in the shell is 2n square. When n is equal to 1, that is 2 electron in the first shell, n is equal to 2 square, that is 4 multiplied by 2, 8 electrons in the second shell, 3 square multiplied by 2, 9 into 2, that is 18 electrons in the third shell. Like that we can find the maximum number of electrons in any shell using this formula. Orbit is circular, the average path is circular, but actual path is fluctuated from the main path, because electron has two types of nature, particle nature and wave nature. The shape of orbital circular I told already. Now I want to discuss about subshell, the part of orbit where the probability of finding electron maximum is the subshell. There are subshell S, P, D, F. These are three-dimensional. The S subshell has S orbital, P has Px, Py, Pz orbital, D has similarly 5 orbitals, F has 7 orbitals. Each orbitals has the capacity of same number of maximum electron, that is 2. So total number of electron for S orbital is 2, P orbital each 2, that is total P subshell 6 electron. Similarly D subshell total 10 electrons, F subshell maximum 14 electron can be present. Shapes of orbitals. S orbital is spherical shape, P orbital is dumbbell shape. The orbitals are expressed by L, that is secondary quantum number. The value of L for S, P, D, F respectively 0, 1, 2 and 3. The n always should be greater than L. N is the principal quantum number, that is orbit, always greater than the secondary quantum number L. So we know already value of L for S, P, D, F. Orbitals are 0, 1, 2 and 3. So we mean here 1s 2, that is in the first shell S orbital has 2 electrons. Similarly 3p4 means third shell, n is equal to 3, p is the orbital and 4 electrons in the third shell. By diagram we can also show, if it is nucleus, this is the first shell, so first shell n is equal to 1, it has 2 electrons. We can show another one. If it is nucleus, first shell, second shell, and this is third shell, n is equal to 3, it has. We want to discuss now Aufbau principle. Aufbau principle. Aufbau principle says electron occupies in the lowest energy level first. So electron will enter 1s first, 1s, then 2s, 2p, 3s, 3p, then 4s, after 4s then 3d will come. Because if you see the orbitals with energy, we can see here, this is energy, and orbitals, this is 1s, 2s, 2p, 3s, 3p, this is 3p, this is 1s, then 3d, 1 2 3 4, and 4s. 3d has higher energy than 4s, but 4s is far apart from the 3d. In the x-axis, 3d has small distance than 4s, so electron will enter 4s first, then 3d. If you see the electronic configuration of any element, say Na has total 11 electrons, 1s it has maximum capacity 2, then 2s it has 2, 2p maximum capacity 6, total 10 electrons enter already, so another left, that will be in 3s. This is the electronic configuration of sodium. If you want to make the electronic configuration of calcium, 20, 1s2, 2s2, 2p6, 3s2, 3p6, then 4s2, not 3d, 4s will come here. If you want to discuss another one, that is transition element, like iron has 26, so 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 20, then 3d6. I also want to discuss the electronic configuration of ions. If you want to make ions of Fe2+, 20 is the atomic number, so the first 4s electron will be lost, the last shell first, so 1s, 2s, 2p6, 3s2, 3p6, then 3d6. 4 is gone from here because last shell will electron first. Another one, if you want to make zinc, Zn2+, this will be similar here, the last is 3d10 and others are similar. The 4s is lost from here. And another point I want to discuss, block elements. The last electron in the orbital indicates the block element. So if we discuss here, sodium, the last electron is in s orbital, so this is s block element. Similarly, calcium also s block element. If we want to say chlorine, the last electron is 3p5, then 3s2, so last electron in p orbital, so this is p block element. The similar case, iron is d block element, d block. Electronic configuration is up to this. Thank you very much for watching this video.